Okay, topic 5 is piecewise functions. So remember, you're looking for the parent graph. Once you have the parent graph, then you can know what's happening at each of those pieces. So this first one is linear. Okay, so we can just plug in our points. So if I plug in -3, that becomes +3/2, so -3, +3/2, so positive 1.5, and then go 3, 1, 2, 3. Now, if you want to do -4, because that's easier, -4 times -5 is 2. 2 plus 3 is 5. And then you would go up 1 and left 2. Now, remember, this is x is less than or equal to -3. So it's going to be a solid point right there at -3 and going up to the left. My next graph is quadratic. Now from here, use your transformations and parent functions. So it goes down 1. So at 1, 1, it would go down 1. Is -1 in my domain? Is it? So I'm asking, is -1 between -3 and 1? It is. So it goes there. Down 1 is 0 there. It definitely is. And 1, 1. Now this is also my domain, but it's going to have an open circle because it's on the edge and there's not a line equal to it. And then plug in -3. So -3 squared is 9, minus 1 is 8. So -3, 1, 2, 3, 4, 5, 6, 7. That's also going to get an open circle. It's going to go like that. It's going to get an open circle because it doesn't have a line underneath. Now the last one is just a nice pretty 3 if x is greater than 1. So 1, 2, 3, open circle, that's okay. Like so. Now my domain, just read it right off the graph, -infinity. But you pick up, this is okay, but you pick up at 1. So -infinity to 1 and 1 to infinity. Okay, now my range, come up from the bottom. The first one you hit is -1, and it's going to go to positive infinity. So your discontinuities, you have a jump at x equals -3, and you have a jump at x equals 1. Okay, there's piecewise functions. Now we're talking about graphs of polynomial functions. So this is using your end behavior. So for 32, it's up and up, so it means it has to be positive at even degree. This is up and down, so it's negative and odd. Negative and odd. Okay. Graphing, I will do 35. So find yours. So positive and odd. So down and then up. Then find your 0. So I take out an x. And I factor more. So your zeros are 0, comes from that. -1 comes from there. And -4 comes from there. So I graphed them, -1, 0, -4. And this goes down, through, and up. Okay? Domain is negative to positive. Range is also negative to positive. Your x-intercepts we just found, 0, -1, and -4. And I don't care about your y-intercept. Okay? Topic 7, zeros of polynomial functions. Now, so all you're doing is just finding your zeros here. So factor to find your zeros. I'm not going to do that. Remainder theorem, remember this is when whatever your C value goes in your box and you do synthetic division. And your remainder is your answer. Your remainder is your answer. Factor theorem. That's when you find your zeros, plug it in, and if your remainder is 0, it's a factor. If it's not a factor. Rational zero theorem. That's your P's and your Q's. So remember, P are your factors of your last term, your constant. So 1, 2, 3, 6. Okay, 6, 9, plus or minus 18, plus or minus 27, and plus or minus 54. Remember, you have to have the plus or minus on there. And then Q are your factors of your leading coefficients. So in this case, it's just 1. So you just take all these and divide them. That's how you find your zeros. Descartes' rule signs, that is your sign changes. So your positive and your negative. So sign change, no, 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 no. So you're going to have no positive possible real zeros. To find the negative, you have to find f of negative x. If it's an odd degree, it switches signs. If it's even, it stays the same. And now just do your sign changes. There's 1, 2, 3, 4, and 5. And then you subtract 2 until you hit 0 or 1. All right. Last thing we're going to do is we're going to find all the zeros, simplify all rational and complex solutions, then give the complete factorization. Okay. So you're going to want to find your zeros doing your P's and Q's. Or you can just guess and check, honestly. Okay, so you're going to find your zeros. So one of your zeros that works is 1/2. So I'm going to put 1/2 in and do synthetic. So 4, 0, 47, 0, and negative 12. Bring it down, multiply, add, multiply, add, multiply, add, multiply, and you're at a 0 there. So now you're at 4x cubed plus 2x squared plus 48x plus 24 equals 0. Now you can factor by grouping. So take out a 2x squared, so you're left with 2x plus 1. Take out a 24, you're also left with 2x plus 1. So you have 2x squared plus 24, and then 2x plus 1 equals 0. So this is going to give you negative 1/2. And this will give you x squared equals negative 12. So x equals, oopsies, plus or minus 2i radical 3. Okay, so you have 1, 2, 3, 4, which is what you need. Now you need to do your complete factorization. So the first one is 2x minus 1. The second one is 2x plus 1. Then you have x minus 2i radical 3 and x plus 2i radical 3. Now, some of you guys on the last test did not actually factor it out, and you got it wrong. So you have to have the i's for complete factorization. Last thing, write a polynomial function given the zeros. Okay, so plus or minus I and 5/2. So you would write f of x equals x minus I, x plus I, and then 5/2 would be 2x minus 5, and then you have to square it. Distribute the x plus I, x minus I, so this is x squared plus 1. 2x minus 5, the quantity squared is 4x squared minus 20x plus 25, and distribute again. So this is 4x to the 4th minus 20x cubed plus 25x squared plus 4x squared minus 20x plus 25. Combine like terms, 4x to the fourth minus 20x cubed plus 29x squared minus 20x plus 25. Okay? Last thing we're going to do is graphing rational functions. I will do 53. So factor it out first. So it's x squared minus 4. So this is x minus 2x plus 2 over x plus 1. Now, you should notice here that those x's cancel. So that means you have a whole. You have a whole at 0, comma, if I put 0 in, this is negative 4 over 1, so 0, negative 4. 0, 1, 2, 3, I have a whole. Boom. Now I still have something left in my denominator, so it means I have a vertical asymptote at x equals negative 1. At x equals negative 1. Now, x-intercept, set my numerator equal to 0, so 2, 0, and negative 2, 0. Sorry, this doesn't want... I flip it this way, it'll work. So 2, 0, and negative 2, 0. To find your y-intercept, plug in 0, but there's a hole there, so you're good. You know your y-intercept doesn't really exist. Now, slant, or I'm sorry, horizontal or slant. This is top heavy. The degree of the numerator is 1 more than the degree of the denominator, so it means I have a slant. So you need to do long division. Start dividing. So this is x cubed plus x squared. Subtract them. So this is negative x squared minus 4x. That's negative 1. There's your slant asymptote, y equals x minus 1. I put those little dots on there and then connect them with a nice dashed line. And then from here, just connect your pieces. And there is your rational function. Any other questions, message me, let me know, stay on the Google Meet.